Hello friends, I am Dr. Adil Khatri from Metastable College of Engineering. I am an assistant professor in Department of Humanities and Applied Sciences. Okay friends, so today we are going to discuss one component system and phase diagram of water. We'll take example of water as a one component system. As we know, as in front of you it is there the diagram of phase diagram of water. Now if you see this, now if you observe this is O, okay, where all three curves are meeting. This area is AOC. We'll discuss this one by one. This area is AOB and this area is BOC. Now this area is of solid ice, where you will find ice, and this is liquid, water in the liquid form. This is water in the vapor form, and these all values are given here. And this is 1 atmospheric pressure, and this is your pressure against temperature. Is that clear? Now consider area AOC. As AOC, we know that water exists in only liquid form. The number of phases here is 1 and the component is as obviously 1. So F is equal to C minus P plus 2 is equal to 1 minus 1 plus 2 is equal to 2. That means it is having 2 degrees of freedom. That means at least 2 variables are required to define any point in this area. What does it exactly mean? Let us see now. Come to the diagram now. Now suppose if I want to define any point in this AOC, I told you already this is water in liquid form and this is one phase in this area. So suppose if I want to define any point in this area, it requires at least 2 variable. How? See, suppose I will select, if I give only one variable, let's say 120 degree, I will tell find a point at 120 degree. So 120 degree, this whole line from here to here, it will cover 120 degree. So you have to specify pressure also at what point. So here suppose let's say at 1.1 atmospheric pressure, so it will be somewhere here. So this is your point. So if you want to define this point, you require 2 variables. Is that clear? So that is why it is called as 2 variable system or bivariant. Is that clear? Similarly, if you see area BOC, here you have solid ice. Okay, so everything will be solid here. So again, if I want to define any point in this area, you require 2 variables, that is temperature and pressure, as the same as this one. So similarly, same principle is applied for area AOB, where you have this vapor. So here also you have to define at least 2 if you want to define any point in this area, you require at least 2 variables, pressure and temperature both. Is that clear? Okay. So degree of freedom in this area is 2. F is equal to 2 for all area, that is solid, liquid and gas. Hence AOBOC, AOC, BOC and BOA is a bivariant system. Is that clear? Now let us see the boundary or the curve. Now this is your melting point curve. That means where solid and liquid are in equilibrium. At this line at OC, solid and liquid are in equilibrium. Now consider this curve OA. Here also vapor and liquid are in equilibrium, and here solid and vapor are in equilibrium. That is your curve BO. This is called as sublimation curve, and this is vaporization curve, correct? And this is melting point curve. So OA, OB and OC, we will discuss these three, and finally we will discuss what is OA dash. Now let us consider the vaporization curve OA. Now we know that at vaporization curve, water in liquid form and vapor exist in equilibrium. That means at this curve we have 2 phases in equilibrium. So P is equal to 2 and C is equal to 1. So the degree of freedom here will be C minus P plus 2, that is 1 minus 2 plus 2, that is 1. So it is univariant system. Let us see how. Now see, in vaporization curve we are dealing with this now OA or AO. Now suppose if I take any point here, let's say 150 degrees Celsius. Okay, at 150 degrees Celsius. Now remember, this is this diagram is not to scale, it is just arbitrarily drawn just for better understanding. So let us consider at this point at 150 degrees Celsius. So I will tell, okay, find a point at 150 degrees Celsius. So it will be somewhere here. 150 degrees Celsius will be somewhere here, correct? Now you no need to specify the pressure. If I define just a temperature that is 150 degrees Celsius, pressure will be automatically will get from here. So it will be somewhere here. So no need to specify, because you are dealing with this line now, not in the area, you are dealing here. So at 150 degrees Celsius, so just if I specify at 150 degree, find a point or to define this at 150 degrees Celsius, you just need a temperature. Or if I tell that, okay, at 1.5 atmospheric pressure, so it will be somewhere here. So 1.5 atmospheric pressure, so temperature will automatically get from here. Is that clear? So this is how it is having degree of freedom only one, because you have to specify only any one of the variable, either temperature or pressure. This is not the case with the area, because area you have to specify two variables. Is that clear? Similarly, for curve, that is melting point curve OC, water in liquid form and water in solid form will exist together. So it is having two phases in equilibrium. So P is equal to 2, C is equal to 1. So again F is equal to, and again it is a univariant system. Is that clear? Similarly for OB, that is sublimation curve, vapor and solid exist together. So it is having two phases, that to two phases in equilibrium and one component system. So F will come as 1. So all curves are univariant. Okay, it require only one variable. Okay, all these curves require only one variable to specify or to define this at equilibrium, that is OA, OB and OC. Is that clear? Okay, now what is that OA dash? Now this, if you extrapolate, if you just extend this from AO, so this is called as metastable curve. Okay, this is called as metastable curve. Why it is called as metastable? Because here the water will not solidify. It is a possible that there is a possibility that you can you cool the water below 0 degree, that means below its melting point, and that water is called as super cooled water. Now the speciality of this is it is metastable, that means not very stable. A slight disturbance will lead to solidify the liquid. That is why it is called as super cooled water. Okay, so metastable curve, you can I have already discussed that metastable curve is also called as super cooled liquid or super cooled water. And I told you as already that if you slight disturb that water, it will convert to solid or it will solidify. Now this is very important for water phase diagram. This is triple point, as I already discussed in my previous video, that triple point, that means all three phases exist together. So solid, liquid and gas, all three phases exist together. So P is equal to 3. Now number of phases is equal to 3 and component is 1. So C minus P plus 2 is equal to 1 minus 3 plus 2 is equal to 0. So it is invariant system. That means this point is fixed. You cannot change anything. You can't change anything here because this point is fixed. This point is O. That means solid, liquid and vapor exist together and this point is fixed. The value of this is 0.0075 degrees Celsius and there is around 4.58, that is 4.58 millimeter of mercury. Okay, 4.58 millimeter of mercury. Now if you see this is triple point of water. So this is fixed, pressure and temperature is everything is fixed. Then only you can achieve this. Otherwise, if you slight change the temperature or pressure, it will either shift towards solid vapor or liquid vapor. Is that clear? Okay, so this is your triple point and this is invariant system. That means it is everything is fixed. You cannot change anything in this point or in this system. Now another important thing to discuss in this phase diagram is critical temperature, and we know that above critical temperature you cannot liquefy the gas. So here the critical temperature is around 374 degrees Celsius, that is very high, and the pressure is 218.5 atmospheric pressure. That means if you go beyond this, you cannot liquefy water, even your pressure is very high. Is that clear? That is what's called as critical temperature. And this is your boiling point, that is 100 degrees Celsius at 1 atmospheric pressure. This is 1 atmospheric pressure and 100 degrees Celsius. So this is your boiling point of water. Okay.